హలో ఎవ్రీవన్, వెల్కమ్ బ్యాక్ టు అవర్ ఛానల్. ఈ వీడియోలో మనం ట్రాన్స్పోజ్ ఆఫ్ ఏ మ్యాట్రిక్స్ అండ్ అలాగే టైప్స్ ఆఫ్ ఏ మ్యాట్రిక్స్ అంటే ఏంటో తెలుసుకుందాం.
Transpose of a matrix. What is transpose of a matrix? Let's suppose we have a matrix. Transpose of matrix, I can denote A transpose. What we do? We will convert A transpose rows into columns, right? 1 2 3 4 5 6. First row would become first column, second row would become second column. So you can see that transpose is interchanged in rows with columns. Then you can transpose of a matrix. You can see order of matrix is 2 cross 3 and 3 cross 2. Order would also get reversed because we would interchange rows with columns. Now let's discuss some of properties of a transpose. Some of the properties of transpose. So what are those properties? Transpose is equals to A. ఎలా అంటే this is A transpose, right? Transpose of transpose is equals to ఏమవుతుందంటే కాలమ్స్ రోస్ అవుతాయి. కాలమ్స్ విల్ కన్వర్ట్ రోస్. A transpose of transpose equal to A వచ్చింది కదా A అలా. నెక్స్ట్ A ప్లస్ B transpose equal to A transpose plus B transpose. You can do that, A transpose plus B transpose. One more thing we have left in product of matrix, order of AB is MQ. The product of two matrices. One more thing you have to remember here, that product of matrix is not cumulative. It is may or may not be equals to BA. This is one of the property. Second one is this product is not cumulative but it is associative. What is mean by associative? What is mean by associative? First I will do BC or I will do AB. I will get the same result, right? Matrix multiplication is not cumulative but it is associative. So just remember that. Let's get back to A plus B transpose. So you can transpose of A individually and transpose of B individually. You can add, then you can get the same result, right? And another thing is RA transpose equal to RA transpose. So if you can take R outside, if you have scalar matrix, how do you multiply scalar matrix? For suppose R 1 2 3 4 have this. So you write down 1R 2R 3R 4R, right? That's mean you have to multiply that R in the whole matrix, right? RA transpose would be RA transpose. That does not impact transposing, does not impact on any scalar matrix. Next one is AB transpose equals to B transpose into A transpose. This is an interesting property. You cannot say that AB transpose is equal to A transpose B transpose because it is not cumulative. If it is cumulative, then it would like, but it is not cumulative. So its open has B transpose into A transpose. Similarly, have you k number of matrix A1, A2, so on, AK transpose, any number of matrix. If we would take transpose, they would open it in a reverse manner. AK transpose, AK minus 1 transpose, and it move up to A1 transpose, and inverse we will discuss later. But to right now, just remember the property. Either we would take inverse of a transpose or transpose of inverse, that would be same. So next thing is types of a matrix. Next thing is types of a matrix. Types of a matrix. That is important thing because so many questions comes on types of matrix, or not exactly on types of matrix, but let's suppose the whatever they have given in the question, right? So we will start with the matrix one by one. What is the row matrix? So row matrix is a matrix in which we have only one row, like this. This is a row matrix. Next, column matrix. Column matrix would be only one column, right? Null or zero matrix, all the entries. So can say here null or zero matrix is all the entries 0, then it is said that this is null or zero matrix. Any matrix can take here any order, it does not matter. It would be always null or zero matrix, like this. So in row matrix would always m into 1. In column matrix has like this. Row matrix of order is 1 cross m, and column matrix of order is n cross 1, because we will always have one column. In null matrix, any order m cross n, we can have any order, it does not matter, right? Next we have a square matrix. In square matrix, a matrix has number of rows. In square matrix, a matrix has number of rows into number of rows equal to number of columns. That is square matrix. Then I have a square matrix of order is equal to n cross n. Then it is a square matrix. Next thing we have here diagonal matrix. Then what is diagonal matrix? Square matrix in which all non-diagonal entries are 0. square matrix of square matrix in which all non-diagonal entries are 0. Now, what is diagonal matrix? So, if I will take a matrix, first of all it should be a square matrix. Let's suppose this is the matrix 1 2 3 0 0 0 0 0 0. So middle line on which all values lies should not 0. That is my diagonal, and other than that all the entries are 0. That is my diagonal entry. Now coming to the scalar matrix. Now what is scalar matrix? The square matrix in which all non-diagonal entries are 0 and diagonal entries are equal. That means I cannot write down 1 2 3. There should be one scale like single scalar. If I will write down 2 2 2 0 0 0 0 0 0, this is a scalar matrix. Next we will go for identity matrix. What is identity matrix? So what is identity matrix means in which a square matrix of all diagonal entries are zeros. In which a square matrix all non-diagonal entries are zeros and diagonal entries are equal. So that means identity matrix 1 1 1 0 0 0 0 0 0. This order of matrix is 3 cross 3, right? Another matrix also I will write in here 0 1 1 0. Order of matrix is 2 cross 2, right? The property identity matrix have that if you would multiply with any matrix, let's suppose I will representing identity matrix I. Then if you would multiply with A into identity matrix is equal to A. If we would multiply it with A with identity matrix from left hand side or right hand side, it will become the same result, right? So that is why it is called identity matrix, because it does not make any changes in my matrix.
Thanks for watching. Please like, share and subscribe the Study Spark.